are used for their communication could be these neurotransmitters. Now, these neurotransmitters are secreted by the nerve cells. So, if one neuron or nerve cell communicates with the other neuron or nerve cell, then they make use of this neurotransmitter. You have the word neuro from the neurons, transmitter, then their role, which is for transmission. And then, of course, the hormones, which are produced by the endocrine glands. So they also function for cell-to-cell communication. So we have these terms that you should know. When we say neuron, they are referring to nerve cell. They're just the same as another term for nerve cell. So you have here the structure of the nerve cell. You have the finger-like projections called the dendrites, and the whole thing is the cell body, or we call it as the perikaryon. So this is the perikaryon. Or cell body. Of course, we have the nucleus. And this neuron or nerve cell has tail part. We call this as the axon. So this is the axon. And this axon is myelinated, comprising the myelin sheath, which consists of the sphingomyelins. It's a lipid molecule, which is an important constituent of the neuron. Okay, the myelin sheath, I should say. So you have neurotransmitter, where what is that? It's a chemical messenger between a neuron and another target cell. It could be neuron or muscle cell, or maybe cell or any cell of the gland. So where is it located and where is it synthesized? Say for example, that one, the neurotransmitter, it's synthesized in the cell body or the perikaryon. After it is synthesized, then it is transported via the vesicles toward the tail part or the terminal part of the axon here. So these are the vesicles. These vesicles are the vehicles for the neurotransmitter synthesized in the cell body. And it's now brought here in the terminal part of the axon for a temporary storage. Okay? So they are placed here in the terminal part of the axon. And what is the hormone? It's a chemical messenger released by an endocrine gland. So it's controlled by endocrine system into the bloodstream and transported there to reach its target cell. So most of these hormones are released via the bloodstream. And of course, it takes time because many of these hormones are released via the bloodstream. And targeting, that's the time that they target the target organ for an action. But for the neurotransmitter, it's quick, it's short time. So it does not pass through the bloodstream. So it targets right away, maybe to the central nervous system, and then you have the sensory, the central nervous system, maybe the brain, and then to the motor neuron to the target organ. So quick, millisecond lang. And then we have the distinction between neurotransmitter and hormone is physiological. As I told you, they don't have difference in terms, they are similar chemically. Now, but physiologically, meaning they differ in maybe in their function, because of course the hormone is secreted by the endocrine gland, or structurally they differ. And of course the neurotransmitter is synthesized by the neuron. Now it depends on whether the molecule acts over a short distance. That's why it's physiologically, because neuron acts for a short distance, only for a shorter time, usually milliseconds. But so So across synapse, here, this is synapse. So found outside the or right after the terminal part of the axon. Or over a long distance from the secretory organ, meaning from the endocrine organ, then released to the blood and to its target organ for an action. So that's how they differ. And since it passed through the blood, as what I have said, then it takes long. Now, say for example, there is fire. Fire! So, it's very quick that you run toward your refrigerator and lift it. So, there is release of adrenaline, or we call that epinephrine. Now, because it's just millisecond, now, its action is millisecond, very quick. So immediately you lifted up it could be the refrigerator or the piano, and let that out from your house when the fire is going on in your house, burning. And of course, that action of the neurotransmitter is just short. Now, what sustains why you can go back and get inside again and carry another and lift another appliance is already the hormone. So what sustains then is the hormone. So nagbalik-balik dito. So pag that quick action is due to neurotransmitter, and what sustains for say maybe an hour of having that epinephrine. So that causes the action during that time of burning. So it's now the hormone. Okay? So that's its effect. Now, a large percent of drugs used in human medicine influence chemical communication. Like for example, you have the antagonist. We'd say antagonist, it's a molecule that blocks a natural receptor and prevents its stimulation. It's antagonist, meaning kontrabida. It blocks the natural receptor and prevents its stimulation. Now, say for example, this is now our receptor, and this is the substrate that binds to the binding site of the receptor. Say for example, now the one, say for example, there is an antagonist here, another molecule that prevents the binding of this hormone or maybe the substrate and that of its receptor. We call that as antagonist. Now, this antagonist is actually used in the pharmaceuticals. Now, say for example, you have a disease caused by a certain microorganism, and of course, the pharma or say they actually study the structure of the substance produced by this microorganism. Say a certain protein, and it has a receptor on your, say, in your body, in your body cells. So when that, say for example, this one, the substrate produced by the disease-causing microorganism sees the receptor, then it can bind. Now, the role then of the pharmaceutical, or the drugs or the medicines, is to prevent its binding. And we call this, what they are producing, as antagonist, kontrabida, that prevents its binding. So, ang sahay, ang bridge. The bridge is the owner. Okay. Kung na ay, say, binding between the sweetheart, sa lalaki o babae, who are in love with each other, then so happen that they have bridge, maybe close friend who is also in love with the other, or maybe with the guy, then the bridge will do something to prevent their binding. The uto niyang girl. Also, the girl may, or say the bridge may act as antagonist that prevents the stimulation of the receptor. Now, we have this agonist, a molecule that competes with a natural messenger for a receptor site. It binds to the receptor site and elicits the same response as the natural messenger. Now, another pharmaceutical, say, help in, or say, principle in producing drugs is to produce agonist. So, this one, the agonist, does not prevent the binding of this hormone, but it competes. Kompetensyahan niya sa bind. If the hormone binds here, so there is no, it does not prevent the binding, but bind ko na siya diri sa iya ha. Mahimo ko na siya ihang lusot. Mahimo ko lusot. So it competes with the natural messenger for our receptor site, or it could be, of course, later on, dili niya puggan, dili niya siya puggan. So later on, naaman siya sa wala pa yung binding site dili, but later on siguro lagot na ning kaning hormone or say kaning siya nga substance, then it will not bind anymore, so kanina siya ang bind. Now, I'll give you an example. Say, katong bridge, dili niya i-prevent from the girl to go nearer to the guy, pero kaning katong bridge, iha pong i-close ang guy. And then later on, mahulog ang buot sa guy. No? Hangtod nga, slow down na iyang emotion, iyang attraction with the girl. Ang katong bridge, dito na hinuon siya mo bind ultimately. So that is the principle also in drug formation. They may produce this agonist, of which the substrate may also bind with the receptor site, but the agonist will be the competitor. Mo-compete siya with the natural messenger for our receptor site. Bubind po siya. Kung mubind ang kuan, ang natural messenger or say ang substrate to the binding, to the binding site or say to the receptor site, then kung walay natural messenger, siya mo puli. Pulihan ba? Pulihan lang ta. Okay, that is competition. Whereas ang antagonist, there is no binding. Wala, di niya pwede ipaduol ang girl. So ang maningkamot yun ang bridge niya, di yun makaduol ang girl sa boy. Iyahan yun ang boy. Okay? Now, a drug may decrease or increase the effective concentration of the messenger. So that's the role of the drug or the medicine. Its target because of this antagonist and agonist. So, there is now inhibitions that will happen with the binding of this natural messenger with its receptor site through this antagonist or agonist. So, there might be decrease or maybe increase the effective concentration of messenger. Okay, now we have here the structure of the neuron. So, I told you this is the cell body, or we term that as the perikaryon. And it has cytoplasm, the nucleus, and these finger-like projections called the dendrites. And we have the tail part, we call that as the axon. Now this axon is myelinated with myelin sheath. Kana siya, sheath na siya, composing these spindumelins. And of course, this sheath consists also of mga swan cells. No? Kanina siya, napod siya a cell within a cell. Now, the purpose of these swan cells is to produce the myelin sheath. So this is the one that produces the myelin sheath. And they act or enhances the action potential propagation here. And what are these here? These are mga different gates. Kani mga gates ni siya. So that is where sodium or potassium would get in or out. Okay? During action potential propagation. Now this is the terminal part of the axon or the nerve endings. And here, this is the synaptic cleft or the synapse. Now here in the nerve endings, there you could see the vesicles, the transport vesicles. Where are they from? They come from the cell body, which carries the neurotransmitter that has been synthesized in the cell body and transported toward the nerve endings. Okay? And that's their temporary storage there. Now, when they are released, I'll tell you later the mechanism of neurotransmitter release, how it would be released. So they would be released in the synapse, and of course there, the neurotransmitter is there, and the neurotransmitter it has a specific receptor again in the postsynaptic endings of the next cell. So i-receive na po din siya, so na po yung action potential to the next neuron. Okay? So that's the expanded picture of the neuron. Okay. There are 5 classes of chemical messengers. You have cholinergic. So you have the word choline. Cholinergic messengers. Amino acid, adrenergic, peptidergic, steroid messengers. Now, all these messengers class, they only stay outside the cell. If this is the cell, they cannot get inside. That first 1, 2, 3, 4. 4. So you have the word peptidergic is peptide. Adrenergic, adrenaline. Adrenaline. Amino acid, so a smaller messenger, and then you have cholinergic, say acetylcholine, cholinergic na. Okay? And they are classified by how they work. So they may activate the enzyme. So what are their role? Activate the enzyme or affect the synthesis of enzymes or affect the permeability or act directly or through the secondary messenger. I'll explain to you later how they work. Now, as what I have said, these 1 to 4 types of messengers are or cannot get inside the cell. They just stay outside and they have specific receptor. Now, the binding of that messengers cause that cause then the signal transduction. We call that signal transduction. Meaning, the binding of this stimulates activates the other molecule. Once it is activated, this again activates another molecule, so on and so forth. So there is activation of molecule once one molecule is activated due to the binding of these different messengers. But for the steroid messengers class, it's different. Steroid. They can get inside. They have receptors here outside, and they also have receptors here inside the nucleus. What about, say for example, there's somebody who is courting a girl. Now usually the boy would just stay in the sala or maybe the outside, say in the yard, no? Now, say pwede siya diha sa sala, but never inside the room of the girl. That should be the rule in the home. So the admirer should not be allowed to get inside the room, just there in the sala. So there, for these cholinergic messengers and up to peptidergic, these 4, we just stay here in the sala. Or maybe here outside, nara na siya sa, dili ganit sa sala, nara sa backyard. Nara sa backyard. Diha ra kataman. Di ka pwede musulod. However, for this messenger, kaning steroid messenger, makasulod siya sa sala, makasulod pa rin siya sa kwarto. Kaya naman, na siya'y na siya receptor here. And then mauban pag yun sa iya ha. And then nanapod siya receptor diri inside the nucleus. And that steroid messenger can able to bind with the DNA and influence the action of the DNA. So that's why when you have when you are sick, say for example you have asthma. If the asthma is very intense, grabe na. Now usually not only anti-asthma is given to you, but it's taken in together with the steroid. Why? Because that steroid facilitates the entry of that drug, that anti-asthma, together with the steroid, and targets right away the DNA. So, pas-pas, very quick ang response sa cell, and immediate ang action. However, you have to suffer also the side effects of steroid because it can influence here the DNA. Then, of course, pwede niya ma-change ang action sa DNA with its binding. Okay, so that's one thing that good. Okay. Now, this one, the main cholinergic messenger is acetylcholine. There are two kinds of receptors for acetylcholine. So, duha iyahang receptors. So, we look at the one that exists in motor and plates. So, where is it found? In the skeletal muscle and the sympathetic ganglia sa nervous system. Now, storage and release of acetylcholine. We have here, say, the nerve cells that bring messages contain ACH stored in vesicles. Now, say for example, ang acetylcholine is synthesized here in the cell body and is brought by the vesicles to the synaptic cleft. So, nasya diha acetylcholine. Whenever there is a stimulus, kung na ay stimulus. Now, the stimulus is, say, what is in the stimulus? There is information. What is that information? Depende sa stimulus. Now, say for example, init. Init. Pag hikapin mo, init kaayo. Now, before di mo na-release, nakuha imong kamot, before ka naka-feel nga init, you have removed already your hand. So, this is how it happened. So, the stimulus which is pain, or say for example, you have a specific stimulus, is now received by the dendrites, and it travels, the information travels in a wave. So, it travels in a wave. That's how information travels. Okay? So, muagi na siya diri paingon sa tail part of the axon. Of the neuron in the axon. Now, so, until it reaches here to the terminal part of the axon. Once niabot na ang action potential sa terminal part of the axon, the calcium, with the arrival of the action potential, is ang calcium nara na siya diri sa gawas outside the membrane. Once the action potential is propagated in the cell, in the nerve ending, then the calcium will bind in the cell membrane of the axonal part, synaptic cleft. Now, the binding of the calcium, or say here, makes these neuroorganic vesicles to go nearer to the membrane and release the neurotransmitter. Okay, by the way, how information travels? But halimbawa, init. Init. So, it is now received by the sensory neuron. Now, how information travels, as what I have said, it travels in a wave. Now, kuha na ito ni isa ka spike, isa ka wave. We say wavelength. The measurement from here to here is one wavelength. Measurement from here to here is one wavelength. So, information travels in a wave. Now, we will get one spike of this, or one wavelength, or one wave of this. So, this is one wavelength. This is one spike. as how information travels. Remember, it travels in a way. That is how, this is action potential. We say action potential, there is energy. And there is what we call as voltage, MV na siya. MV, millivolts. Kung ano kanang high voltage, millivolts. Okay, so how information travels, how a spike or a wave is created. Now, at this refractory period, wala pa na-receive ang stimulus at this time. However, pag receive karon sa stimulus, there is what we call as depolarization. Kung mag-depolarization, meaning that is up here of the spike. Now, ang from negative 70 MV, it reaches ang voltage to positive 40 MV. This is now the millivolts. So that is up here of the spike. Now, di pwede nga diha siya taman. It has to go down. So we call this downhill. What is this downhill? Now, this downhill up to the repolarization, it reaches until negative 80 millivolts. Okay? Now, what happened in the depolarization? Now, class, actually, a membrane is negatively charged. The membrane is negatively charged. And here comes the sodium, which is positive. Positive outside, diri potassium diha. Potassium. Okay? Now, this is what happened during repolarization. Wala pa stimulus. However, when there is already stimulus, now, there is what we call as depolarization, as what I have said. What happened in depolarization? Here, the gate is what? The gate opens up for sodium. So this is actually the opening of the sodium, the sodium gate. Sodium gate is opened up. That is up here. Here, naman tayo potassium diri sa sulod. Now, here, there is coming out or pumping out of sodium channel. Now, during depolarization class, sodium gate is open, potassium gate is closed. Closed ang potassium gate. Na ay mga gates ni siya. It's ligand gated. Na ay mga gates. Now, when there is already information travel, ang mahitabo, sodium is permeable to the membrane. So, musulod ang sodium, kaya nga naman, this gate is open up for sodium. Ang potassium wala. So, what happened? Ang negatively charged, may mo siyang positive. So, dili na siya negative diha. May mo na siyang positive, kaya nga naman, sulod ang sodium. Okay? So, pag sulod sa sodium, wala ang negative charge sa membrane. Now, dili pwede nga always negative ang membrane. No? So, that destroys its function. So, the role now of cell is to open up the potassium gate. So, ablihan na po niya ang potassium gate. So that potassium will get out. Remember, ang potassium has positive 1. Ang sodium has positive 1. So, the role then, or say, what happened to this? What will the cell do is to pump this sodium out. So the pumping of this sodium is, this is now the downhill of the spike. The pumping of the sodium out is the downhill of the spike, and the opening of this sodium gate is the what? The depolarization, the uphill of the spike. The opening of the potassium gate, I should say, is actually the repolarization. No? This is the time where, or the downhill of the spike, then, or we call that as repolarization. It reaches up to the negative 80 millivolts. So, sige nagawas o potassium. Sige nagawas, hangtod nga, manegative na po ang membrane. And the cycle goes on. That is how it happened until it reaches here. So, when the action potential reaches to the terminal part of the axon, so nag-positive, niabot ang action potential diha. Then, calcium is attracted. No? Calcium is attracted, so it binds to the cell membrane, and the binding of calcium in the cell membrane causes the release of the neurotransmitter. And the neurotransmitter in the synapse will bind again to the next cell. So, you have here